All right, recording's re-rolling for this last detail I want to mention about the lab. By the way, just got an email. Looks like school is closed tomorrow, so I'm definitely glad we're doing this lab today because this will be the end of the week. All right, so you guys see a velocity versus time graph, right? We've done lots of velocity versus time for lots of different scenarios. I want to hone in on here. This time zero is going to be the point of the collision, right? So here's the point of the collision, which means that this whole graphical space refers to some kind of post-collision scenario, right? Okay, because here's a technical detail that I might add on to the end of this, right? Because if your momentum numbers don't add up, what if your momentum final is less than it is initial? In fact, what if it is consistently half of what it was initially? So you start off with like, I don't know, like 12 kilogram meter per second, and then after the collision, it goes down to like 6, and that happens consistently, which is something that I've seen in past years, like over and over. That's a pretty consistent thing. And I know why, right? And I asked students, well, did you use this exact procedure? And they said, oh yeah, this is what we did. It's like, oh, okay, well, I can tell you what happened. Now I'll show you guys right here. So this would be the case where there really is a little bit of friction, right? And that's involved too, right? So this is not exactly frictionless. And what some students do is they say, okay, well, instead of using the speed gauge, I'm going to calculate, let's do the whole distance over time procedure. So how far does it roll and how much time? We can divide those two, distance divided by time, and get an idea of speed, right? But what they've done, what they do, you don't have to do exactly this, but if you do this, if you do the stopping distance, like roll to a stop, and say how much time does it take to roll to a stop, right? Then, well, okay, here's how that would play out. Where it wouldn't be exactly an idea, but how you can sort of fix this, right? Here's the post-collision speed, like bam, right? And this thing rolls. Now, if it was truly frictionless, guys, if it was truly frictionless, what would the rest of this graph look like? Yeah, just a flat line, just constant velocity, and you just like go on forever, right? Okay. But if it rolls to a stop, what does this graph look like? Yeah, goes all the way down to like 0 meters per second, right? Wouldn't that be true? Right. This is the time you do on your stopwatch, tick tick, right? This is the stopping time. And what property of this graph is the stopping distance? Area of that triangle, right? Because meters per second times seconds gives you meters. It's some version of that, right? Right. So when you do total stopping distance divided by the stopping time, you're not getting an instantaneous velocity. You're getting a what kind of velocity? Average, right? That's what you guys thinking, right? Average velocity, right? Which is like right here on the graph. I'm going to call this V bar. If you ever see a bar, notice that's not an arrow above that. It's a bar. That means average, right? So it's the same thing as average velocity, right? Which is like right here, which is like halfway up, isn't it? So if you do the average velocity over the stopping time, you guys see the area of this here rectangle is the same thing as the area of that triangle. They're both referring to the same distance, right? But what you're really interested, if you're really trying to keep track of momentum and conservation of momentum, is you don't want the average velocity. You want the instantaneous, like post-collision velocity. You want this one right here. Do you guys see what this is in terms of this? What is this in terms of this? Twice. So the actual instantaneous post-collision velocity is 2 times V bar, 2 times the average, right? And V bar is the stopping distance divided by the stopping time, okay? So if your momentum values are half of what they were to start with, then that's probably why, right? All right, any questions right now? All right, so I'll see you guys back in the lab area, go around, help you guys out. And yeah, all right, and then that'll be the conclusion of the week for Hurricane.